in chapter 1, we'll start on page 155, and we're going to be talking about functions. So we're going to represent functions a different way to review this, and hopefully it is all review. So if I had a domain and a range of a function, and we name the function usually something like f of x, functions only adhere to one rule. What rule is that? No domain can hit two different numbers. So if I start pairing up numbers here, is that a function? Yes. Okay. What if I started doing this? Is that a function? Yes, that's a function. You can have two domains going to the same range. And in this case, the domain has 4 numbers and the range has 2. So actually, we should go into the range and get rid of those 2 that don't belong. If a number in the domain has a line in it, it's actually in the domain. And in order to be in the range, it has to be hit by something. Okay, but this is not a function. The reason it's not a function is 5 is not allowed to hit 2 different numbers. Okay, so you can also list a function as a series of points. So I could say g of x equals 6, 0, 5, 1, 2, 0, and 3, negative 7. Is that a function? How do you know? You look for repetitive x's. We have 6, 5, 2, and 3. Is it okay that 0 shows up twice in the y's? Yeah, that's totally fine. But if I added another point, 6, 2, it ceases to be a function. What if I happen to write 6, 0? Is it still a function? Yeah. As long as 6 always goes to 0, it doesn't matter how many times that happens. So graphically, how do you tell if something is a function? You do the vertical line test. So if I had a parabola and then I had a vertical line, if I run this vertical line across, does it hit more than once? No. What if it doesn't hit at all? What if this stops here? Is not hitting at all okay? Yeah, that's fine. You just can't hit twice. So if I were to draw a circle and then do the vertical line test, why is that not a function? And why is hitting twice breaking the function rule? So this x might be 2, and then the y could be 1, 2, 3, 4, 5. So that point is 2, 5. And it's also 2, negative 2. So the vertical line test measures, do we ever have the same x hit 2 different y values? So number 1 says, determine whether each relation is a function. Assume that the coordinate pair x, y represents the independent variable x and the dependent variable y. So I don't know how much they're going to get into this, but independent variable means the input, which is the x value, and dependent variable is the output and the y value. What that means is independent is telling us that variable changes however we want it to. It's totally independent of anything. We pick any x we want. But the y values associated with those x values are totally dependent on our choice of x's. So if you hear independent and dependent, independent is the one you get to pick by yourself. Dependent is chosen by your selection of the independent variable. So if you turn the page You're going to go all the way through to 18 doing that vertical line test. How do you, in 7 through 12, how do you tell if it's a function? You could graph it. How do you graph number 8? Well, the trouble is, this is not y equals the absolute value of x. It's x equals the absolute value of y. It's going to be either a greater than or a less than sign, right? So, so y equals x squared is a vertical parabola. What does x equals y squared look like? It's a sideways parabola. And that is not a function. So basically, how do you tell if it's a function? You look at the y variable. If it's y equals, it has to be a function. If it's not y equals, it might not be. Anytime you have y squared, it won't be a function. Anytime you have absolute value of y. So number 7, 7 is x squared plus y squared. This x squared allows for duplicate y values, and the y squared allows for duplicate x values. So the y squared is not a problem, or sorry, the x squared is not a problem, but the y squared is. All right, and then if we start in 19, it says, use the given graphs to evaluate the function. 19. So this is actually really easy. We have 3 questions to answer. Letter A says, what is f of 2? Looking at the graph, what is f of 2? Well, what's the y value when x equals 2? 5. What is f of 0? 1. What is f of negative 2? Negative 3. Okay, and then we can go down to where it actually has equations. So like 27. Oh, it's the same thing. So 27 just refers back to the graphs on the previous page. Okay, easy enough? Okay, good luck. We